my name is Alicia, and today I will be discussing motion maps and helping you use them. So, right here, I just quickly drew an example of what a blank motion map would look like. So, you have your origin here. The numbers to the right of the origin are moving in a positive direction, and the ones to the left are moving in a negative direction. And here is what you will be placing on this motion map. And this represents a second. And these arrows indicate which way the object in motion is moving. So as I write right here, um, it is a lot easier when you look at examples and have a position versus time graph, because that is where you'll be getting your information for this from. So let's do an example. And first, what I like to do is just label this 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, 4, 5. And so time is in seconds and position is in meters. So I like to look at this individually. So this is going to be our line A right here. Oh, right here. So it took line A 4 seconds to go up 2 meters. So if you remember rise over run, I'll write that in the corner. Rise over run, 2 over 4, so the slope is 1/2, which will come in handy. So, or it might not, it just depends on how you do it. So this is our line A. And then let's choose a different color for line B. We'll do green. Line B stays, oh, I totally forgot to mention this, but line A is moving in a positive direction, and we know that because it is moving up, which means it's going to be moving right on our motion map. Okay, so this is going to be our line B. Line B stays constant for 1, 2, 3, 4. We know it stays constant, or it's just not moving. We can say that. It's not moving because it is a flat line, so it is not moving up on our position graph. So we know that for 4 seconds, our motion map will be still. And then let's do a yellow for line C. Oh, well, you can't really see that, but it takes 2 seconds for line C to go up 1, 2, 3 meters. So rise over run, it's going to be, you just can't see that. Let me write in orange. 3 over 2. So let's look at our motion map now that we have all of our information figured out. We can also label this 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Oh, that is a 4 meters. So let's look. We start at our origin, okay? Something helpful. Well, actually, this is a little tricky with motion maps. You must include the 0. So our motion map, our line A, would look like this. 0 seconds is where we start. Something that actually really helps me is knowing that, this is kind of how I do it. Here's our 0 to 2 meters that we need to travel in 4 seconds. So I know that after I place this dot, it takes 4 seconds for me to get to here. So that's already 1 second, and then I evenly fit them. 2 seconds, 3 seconds, 4 seconds. And this is also where your slope comes in handy. Here's our 1/2, because every half of a meter, we put a second. Okay, so make sure you include this 0 seconds. Another way you can think of this, or when you're plotting your points, you go 1, 2, 3, 4, 5. I am plotting 5 dots. Now, when you get to your constant, when you get to your line B that is not moving, you count 1, 2, 3, 4. So line B does not move for 4 seconds, but you need to include this 0 second. Once again, you can do it as 1, 2, 3, 4, 5. You have to include it. So another way you can think of it is that you will always have one more dot than, switch colors, you will always have one more dot than you do seconds over on the time and position graph. And now, let me go back so this is clearer to see. Now we go back and it takes us 3 seconds to go, no, it takes us 2 seconds to go 3 meters. So we are going from 2 to 5. It takes 2 seconds. So I will plot my final here. And then it takes 2 seconds. So this will go in the middle. Another time where the slope comes in handy, because you know every 1.5, you will place a dot. Okay? You will plot a second. So now that we have all of our dots plotted, we must draw arrows. I recommend drawing arrows as you go, but for this first example, I clearly did not do that. So our arrows will go like this. Boop. In this direction, because that is where we are moving. You do not put arrows for when we stay still, because we are not moving. And make sure your arrows are relatively the same size for when you're doing stuff like this, like per line, because you don't want to have an arrow like this and an arrow like that for over here, because that just wouldn't really make much sense. So here we go. That is how we do that. Sometimes when you have an object moving at a constant speed, you will add these little marks to show that, okay, this line, the object was moving at a constant speed. However, you cannot do this at the same time as you have these, because that will, that basically says that this line is moving at the same constant speed as this line. So it's moving as fast, which is just not true. So we cannot have that there. So when you choose, if you choose to write, or when you choose to write in these little dashes, you have to choose, okay, it's either going to be this line is getting the dashes, or this line gets dashes.